But let's get started. Week 1 measurement, volume and capacity, and we're looking at 3D shapes. All right. So 3D, 3 dimensions. Okay, here's an example of what we're talking about when we say 3 dimensions. So we have a rectangular prism in front of us. All right. And if we are talking about 1 dimension, we're only talking about the length. If we talk about 2 dimensions, we're talking about the length and the width. That'll give us a 2D shape, a rectangular box. Okay. 1D shape, that's just a line. 2D, that's a rectangle. All right. Then if we add a 3rd dimension now, and the 3rd dimension in this case is height. Okay, which makes this look a bit strange because, excuse me, the width looks like the height in this case. But imagine this rectangular block was flat on the ground. All right, then it would be this rectangular block here, flat on the ground. Okay, with a length and a width. All right, so there is the length there, there's the length there, there's the width there, there's the width there. So I'm just relating the length and the width in the 2D shape on the left to the length and the width in the 3D shape on the right. Okay. Hi, Emmanuel. Good to see you again. Hello, everyone. All right. So pretend the 2D shape is flat on the ground. Okay. Then the 3rd dimension we add to it is this height dimension. We just go up. All right, to add the 3rd dimension, and that will create volume. All right. And if our units for all of these dimensions are centimeters, length in centimeters, width in centimeters, height in centimeters, then the volume will come out in centimeters cubed. All right. The same story. If they're all meters, it'll come out in meters cubed. If they're all millimeters, it'll come out millimeters cubed, etc., etc., etc. Okay. So when we talk volume, we need 3 dimensions, and we multiply them all together to get our volume answer. From there, we can change to capacity. We're going to have a look at that later on. So usually they first ask you to take dimensions, multiply them together to get volume, and then they ask you to work with capacity after that. All right. Are there any questions so far with this diagram and this understanding of 3D? All right. So when we talk volume, we're talking about 3D, 3 dimensions. Volume always has 3 dimensions. Hope everyone's okay. Feel free to ask any questions. Speak, don't hold your peace. Don't keep quiet, always talk. All right, always ask us. Okay. Now, in terms of the volume formulae, they're always given to you, which is excellent. The formula are always given to you, always. Maybe in different formats, they look a bit different to what you're used to. Sometimes they use letters, sometimes they use words, but the formula will always be given to you. You don't have to remember them, which is really cool. All right, very good news for you. Okay. And then we're going to look at the 3 basic 3D shapes. All right. These are the 3 shapes that we work with in math literacy: the triangular prism, the rectangular prism, and the cylinder. All right. So we're going to look at the volume of these 3 shapes. Now, what's special about these diagrams here is that in all these 3 shapes, the base shape, you should know how to work out the area of all the base shapes in these 3D objects. The triangular prism, the base shape is a triangle. In the rectangular prism, the base shape is a rectangle or a square. In a cylinder, the base shape is a circle. So you should know how to work out the area of all those 3 base shapes. Now, why do I keep on saying area? Because when you work out volume, all you're doing is you're taking the area of the base shape and multiplying by the height to get 3D volume. All right. Area of base shape of a rectangular prism, which is length times breadth or length times width, multiply by height. An area of a cylinder base, which is a circle, pi r squared, times height. Triangle, area of the base, which is a triangle, half times base times perpendicular height, times height. Okay, so if you know how to work out the area of a triangle, a rectangle or square, and a circle, all you do is you multiply by the height. That's volume. Okay, so let's see us creating these formulae. Now, you don't have to remember these. These will be given to you, but it's good to see how we build them so you can understand all the letters that are inside there. All right, so for a triangular prism, like I said, you take the base, which is a triangle, all right? And for the formula for the area of a triangle, we need half times. In fact, you guys can tell me, what do we need? Who can tell me what we need? Someone out there can tell me. Who's out there that can tell me what we need? Giso?
Yeah, so just look, there we go.
Hey, Giso, how are you?
I'm getting yourself.
Good. Tell me, what do I need?
I think it's 1/2 times base times height.
All right, I'll say B for base.
And
times.
H for height.
Okay, now hold on, don't go anywhere. I'm going to put those letters onto my diagram. So on my diagram, are you happy that I put my base letter over here? And then the height, I'm going to have to squash it in, but that'll be my height there. Oopsie, sorry. That'll be my height there. Okay, you happy with that?
Yes.
All right, that'll give me, so this part here, so you happy that this part here will give me the area of the triangular base?
Yeah.
How do I get the volume now?
The volume.
Yeah, so this is just the area of the base. How do I get volume now? I need to multiply by one more dimension. There's a clue there. So on the left-hand side there, find the area of the base and multiply by the
height.
The height. Okay. So this is, you've given me the area of the triangular base. Now I need to multiply by the
height.
The height. Okay, so I'm going to put an H there. So this is the height that we're talking about, right?
Yeah.
You happy with that? Okay.
Yeah.
So this formula is done now, Kagiso. Now, Kagiso, can you tell me, don't you think it'll be confusing that if they gave you a formula like this, that there'll be two H's in the formula?
No, it's not really usual because I've never seen one like this. Usually, when we calculate the volume using this, it's 1/2 times height. No, times height times base. Sorry, times height.
Okay, so that first part there is for the triangular base, and then for the volume, you got to still multiply by the height of the triangular prism, hey?
Yeah.
Which gives us another height, doesn't it? Yeah, so
I'm
we
a
got
bit confused now.
Yeah, it is confusing. No, it's right that you are confused, because in the triangular prism formula, the triangle, if I draw a triangle here, stay with me. Now, if I draw a triangle here, and I say, what is the area of the triangle? You need the base of the triangle, right?
And the
And
height.
then you need a height, which is this dotted line that must be at 90 degrees, right?
Yeah.
Okay, so I'll put there in red that this dotted line is the height. So in an area of a triangle, which is now the base of my triangular prism, I've got a B and an H for height, but that's only in the triangle. I still got to multiply by this triangular prism's height, don't I?
Yeah.
Yeah. So this means that the formula will actually, sorry, yeah?
I want to, okay, is length like literally involved in this calculation or not? Will there be length or not?
Not the triangular prism. That'll come in rectangular prism, yeah.
Oh, okay. Thank you.
So it's absolutely normal to be confused with two H's in this formula, because one of the H's comes from the triangular base, that perpendicular height there, and the other H is the height of the triangular prism. You see those two different heights?
Oh, yeah.
Yeah, so it's absolutely normal to be confused. So what happens is students often get confused with this formula specifically because it ends up being two heights in the formula. Now, if they don't specify which height is which, it can be very confusing. Although you're safe in the case of the volume formula because you're multiplying everything together, whether you multiply this height here first, or you multiply this height here first, it doesn't matter because everything's getting multiplied together. The order doesn't really matter. But what I do when I teach this is I call this height here in the triangle a different name. So what I use is I use the perpendicular symbol like that and that height there. So I give it a symbol, the perpendicular height of the triangle, which is this one here, this H here. So this is the perpendicular height of the triangle. And then you can use another H. Sometimes they use a capital H to make it look different.
Can you
But
say height squared?
Can you say, sorry?
H squared.
Eventually it will be H squared. You absolutely, no, sorry. I can't say that because the heights could be different. If they were the same, you could. If they were the same value, you could. But these are two different heights. So we're gonna come up with a problem just now where, say, for example, the perpendicular height could be 4 centimeters, and then the height of the triangular prism could be 10 centimeters. So we can't say H squared because they're different, but they are definitely two different heights. Are you happy that they're definitely two different heights?
Yeah.
All right. So just remember that. The one height is going to be from the triangular base, and the other height is going to be from the triangular prism. Okay.
So when we name the formula, we say 1/2 times B times H times H.
Yeah, you can say H. So they'll give you the formula. You might see two H's. They won't even put that symbol there. They might even just put two H's. Sometimes they put a small h and then maybe a capital one like this. All right, to make them look different. Okay, you got to know that the small one is from the triangle and the big capital H is the height of the triangular prism. Okay. All right, you happy with that?
Yeah, I'm happy. Thank you.
All right, thanks, Cecil. Thank you very much. All right, so be careful of the triangular prism formula because it's got two heights in it. One is for the base triangle and one is for the height of the triangular prism. All right, so be careful with that one. Okay. All right, I need someone else. Kagiso unfortunately got the harder one. Is someone else going to tell me about the rectangular prism? Everyone should know this one. If Kagiso's still there, maybe she can help me with this one. This is an easy one. This rectangular prism.
Rectangular prism, length times breadth.
Yes, you got it. Length times breadth. And then you just have to times by? Height. Okay, we're going to call it small h here because we don't have any other h's to worry about. Well done. Good job. While you're with me, let's do a third one. Let's do the last one here. While you're with me, you've got it. All right. So this is a cylinder. The cylinder base is a circle. All right. So how are we going to do this one?
Usually in my school, we say 2 pi r squared or 2 pi height.
Okay, you're very close. So we need the area of the circle, which is pi r squared. Okay, and then you need to multiply that again by the height. Okay, the reason why you say 2, that's when you're talking about the surface area of a cylinder. Okay.
Okay.
All right. But don't worry if you're like, well, when do I use it to? When do I not use it to? They will always give you the formula. Okay. We just got to know what the letters mean. And the R here, what does the R stand for in this formula?
Radius.
This radius. Very good. Well done. You know your stuff. Kagiso, thank you so much for all your help. I appreciate it.
Thank you.
Thank you. All right. So the radius, let's draw a little circle here on the side. So the base of this shape here is a circle and it has a radius from the center to the edge of the circle, which we call R. Okay. Well done, Kagiso. Very good. Yes. Now, ladies and gentlemen, who can tell me what is this funny thing here? What is this funny symbol that I wrote down here? What is this thing? Pi. Yes. Well done. Good. You guys all know that that is pi. Yes. Everyone in the chat saying pi, 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 pi. All right. That is pi. Who can tell me what is the value that we use for pi? What value? 3,142. Ben's already there. It's like, sir, come on. You can't catch that. 3,142. All right, that is the usual value for pi that the examiner, yes, you guys all know it, that the examiner will give you for pi. All right, so you don't use the pi in the calculator, all right, which is down here on the calculator. Don't use that one. Usually they tell you to use 3,142, so you use 3,142. Just get used to it, use 3,142, all right? R is the radius, which you know how to get, and again, H is the height, which is the height of the cylinder. All right, yes, you guys know it. Okay, so those are the three formulae that we have to remember to use. Those are the three basic shapes that we're going to do. So let's start from the bottom. From a cylinder, they give you pi, 3,142. R is the radius, you've got to square it, and then you multiply by the height. So this first part here that I'm highlighting in yellow is the area of the base shape, which is a circle. All right. Then the one in the middle is a rectangular prism. This is the easier one, length times breadth times height. Okay. And this part of the formula, length times breadth, is the area of the base shape, which can be a square or a rectangle. All right. Triangular prism. This one can be tricky. It doesn't often come up in exams. If it does, you've got to be careful. They will give you the formula, but you've got to know which height goes where. All right. So this part that I'm highlighting here is the area of the base shape, which is the triangle. Okay. So this shape here, this triangle, you got to know the triangle formula, which is base times height. Excuse me. You still need to multiply by the height of the triangular prism. So there's two heights actually in this formula. Be careful. Don't let them trick you. Don't let them catch you. They might use a small h and a big H to differentiate. Okay. But it doesn't really matter which one you put first, as long as you're putting both into the formula. Because with multiplication, it doesn't really matter. Okay. Here we go. We're going to take a break here before we hit the questions. Ladies and gents, take a break and think about this.
Very cold, sir.
Boy.
Good afternoon, sir. How are you?
I'm good, man. Yo, it's cold. How are you doing?
The best option right now is a nice cup of hot chocolate.
Hot chocolates, coffee, tea. You know what's also good? Knorr cup of soup also works for me. I like the Knorr cup of soup in a packet. You just chuck it into some hot water. I like the chicken noodle.
Wow. Yes, it's time to keep warm. The only problem is going back to school in this cold weather.
You know, I work at a co-ed school, and the boys they got their long pants on, but the girls don't have long pants. They're struggling. Yo, they got blankets and tracksuits, and oh, it's tough, ladies and gents. It's tough. 9 degrees. Oh my gosh, Yamo.
Also those. Also those. It's very cold. It's very tough to focus in class when it's like this.
Yeah, no, this is not fun, man.
Even if you don't want to work, especially when you're working like outside there, yo.
No.
And when you have the mean teachers at my school that want the windows open, they do not want you to close the windows.
And those ones
so they can relate.
Yeah. They want the window open. They want the door open for fresh air. They say fresh air. Keep fresh air. Yeah,
but window. Why is it so cold in the class when you're so many vets?
Yeah, they want the windows open when it's freezing cold. Guys, it's crazy. I can't handle it. I'm struggling with this cold. I don't know. Kia's laughing there, but I'm sure you cold as well.
I am, because imagine it being so cold and then we don't even have electricity.
Yeah. I don't know what you guys are doing. I don't know what you guys are doing. You know, in Durban, we're okay. We can manage without a heater. It's still cold, but we can manage without a heater. But there's some places in South Africa, you need a heater.
Yeah, I
or
just got
something.
like a communication memo from our municipality telling us that we won't have electricity from 8 until 5 o'clock tomorrow. I am not okay.
Why?
I'm not okay.
I mean, that's power.
Yeah,
Yep.
it's not.
Hey,
Bianca says, if you're the person that sits in the front desk next to the door, then you are the coldest person in the classroom, and then you complain. Yeah, Bianca. Shame, that person that's right next to the door. And they always ask you, that person, that they sit down and they say, sir, please can I close the door? Yeah, sure, close the door. But some teachers don't do that, eh? They say, no, 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 leave the door open. And then you just got to sit there and suffer.
You get
Yeah.
detention for closing the door.
Yeah, you just get shouted at for closing the door because it's so cold. Guys, it's cold. Please stay warm. Coffee, tea, hot chocolate, cup of soup, whatever. Just don't put Mari biscuits in your hot beverage, whatever you do. Okay, because it's just
please don't. It's not allowed in this class.
no, we don't do that here. We don't do Mari biscuits and hot beverages. Okay, that's not us. That's a different class. We don't do that here. All right, guys. I hope you've had a nice little break. Ah, we're fighting with a cold. Yes, we always fighting this thing. I can't deal with it, man. Yes, someone must just come now. There's a friend of mine that loves the cold, and I just don't understand him. You know, I'm starting to rethink my choices and friends. You know, I don't understand how can they just love the cold. All right, so here is the question we're going to try tonight. Hopefully, this is challenging enough to warm us up. You know, use your brain and let that work, and then warm the rest of your body. Let's have a look at this one, okay? So it says here, Mr. Rampedi is working as an intern at Cova. I think it should be Clover, but anyway, Cova Company in Durban. There is Clover in Durban, but maybe it's Cova. The company designs boxes and other containers for dairy products. Okay. He is required to work on design for infant juice cartons as shown in the diagram. So this rectangular prism here is an infant juice carton. Okay. As shown in the diagram. All right. Let me scroll down a bit. There's got to be more. Here we go. So on the left, we have the picture of the juice products. And on the right, at the bottom here, we've got the dimensions of the product. Okay. Now, just a little tip for examinations. All right. When you're dealing with diagrams and text, okay, it's a good idea to transfer all the information from the text onto the diagram. It doesn't take long. Okay, but you won't look at the text and the diagram at the same time. You'll pick one to look at for your information. And I'm sure if you're like me, you're a visual person, you're going to look at the diagram for your information. Now, there's nothing, usually there is stuff on there, but if there's nothing on there, I like to transfer all the textual information onto the diagram. So my length here, I'm going to say is the bottom, which is 5 centimeters. My breadth, they say, is 0, 0, 5 meters, and already we got a problem because we got centimeters and meters in one question. It's not good. It's no good. All right, it's no good. We can't have meters and centimeters. But anyway, let's carry on. The height is 10 centimeters. So 2 dimensions have got centimeters highlighted in yellow, and the 1 dimension is in meters. Not good. All right. Yes, Tando, we're going to have to convert that. It depends on what they want in the question. So before I convert, I want to see what the question wants. If the question wants centimeters cubed, I'll put them all centimeters. If the question wants meters cubed, I'll convert the centimeters to meters and I'll make it all meters. So I'm waiting to see what the question wants, and then I will convert. But you know, we all know we're going to have to convert 1 or 2 of these dimensions to make them all the same. All right. So there's the diagram. I put the dimensions in. Here we go. Note at the bottom, the dimensions of the base are the same. The dimensions of the top. Yes. So they're saying the base is the same as the top. That's fine. I'm happy with that. It's a rectangular prism. Has to be like that. Okay. Here comes question 1. Determine the volume of each juice carton in centimeters cubed. So we're just going to do this one here on the right-hand side. Okay. And we're going to work out the volume in centimeters cubed. So there we can see that they're asking for, and I'll highlight it in yellow again, for centimeters cubed. So like, as was suggested here by Tando, we're going to have to, and Isabella, we're going to have to convert first. Okay. So you're going to have to convert this 0.05 meters to centimeters before you work out the volume. I'm going to give you guys 2 minutes to work out the volume, and then we're going to check. Please put in chat when you're done. Just write D for done or a thumbs up or... Yes, Tanya. So centimeters cubed means you need 3 dimensions multiplied with each other. And there they are on the formula. You've got length, breadth, and height. All right, so that's what the cube means. You are multiplying 3 dimensions to give you volume, which we have length, breadth, and height. So when you multiply those 3 dimensions, your answer will be centimeters cubed. Just change your meters first. All right, once you've done that and you got an answer, just type done, put a thumbs up, and I know that we can move on. We're going to work this out, but it should take you 2 minutes. A conversion, and then throw into the formula to get the volume in centimeters cubed. Okay. All right. We've got the people saying done already. That's good. Awesome. 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 All right. 1 more minute and then we'll go over it. All right. Let's have a look. Okay. So we've got 5, 0.5, and 10. Okay. So let's have a look here. V for volume. The length was 5 centimeters. I'm going to multiply, and I'm going to do the conversion inside the sum. You don't have to do it like this. You can do it on the side. So you can say that the B for breadth is 0.05 meters times 100, which will give you 5 centimeters. You can do that on the side first. Okay, you got to show it. All right, you must show it. So you can either show it like that first, but what I like to do, I'll leave it there, and I'm going to do it in my formula as we go. But I'm just going to put a bracket around it. So I'm going to say 0.05 meters times by 100. That'll convert to centimeters. And then I'm going to multiply by the height, which was, if I'm correct, 10 centimeters. Okay, so I'm going to come in the new line and just show the marker. By the way, I have converted it. It is 5 centimeters. And now my sum looks like this. And then you get your calculator because it must do the work for you, because that's why you bought this thing. It must work for you. And you say the answer is 250 centimeters cubed. Okay. Are we all getting that? Yes. All right. If you're not getting that, if you have any questions, please remember. Yes. So 250 centimeters cubed. If you have any questions, ladies and gentlemen, please shout. All right. If you're not getting that, it's like, hey, sir, hold on. What's happening there? Then please shout. Yes, you should all be getting 250 centimeters cubed. Okay. All right. Moving on to the next question. Here it comes. I told you it was going to happen, right? Let's say this is 1 and this is 2. Once you work out the volume, especially when you're talking about liquids, they're often going to ask you now to convert to capacity. Okay. And we spoke about this on Tuesday. They have to give you a conversion when you're going from volume to capacity. So there it is there. They say hint. That's so cheeky, you know, hint. They have to give it to you. It's a hint. No, they have to give this to you. It's not a hint. You have to give it to me. So there it is. 1 centimeter cubed is equal to 1 milliliter. All right. So how many liters do we have in each carton? All right, you guys can do that. And then we're going to check. When you're done, let me know. Say done in chat, and then we'll go over this one. How many liters in each carton? If each carton has 250 centimeters cubed. So use the conversion. Be careful, it's a two-step process, eh? Use the conversion to get to milliliters and then do something with that to get to liters. So it's 2 steps you have to do. And then just say done in chat when you're done. Yes, Kagiso. But the question's not wanting milliliters, you're right, but the question doesn't want milliliters, it wants liters. You will have to change that figure that you've given me into liters. Right, remember we showed you that on Tuesday. How do you go from milliliters to liters? There we go, Isabella. All right, good. Right, looks like everyone's wrapping up now. Excellent, good. So the first thing we're going to do is change the centimeters cubed into milliliters. It's a 1-to-1 conversion. 1 centimeter cubed, 1 milliliter. If I've got 250 centimeters cubed, straight conversion. 250 centimeters cubed must give me 250 milliliters. Now, to change this to liters, we know that there's 1,000 milliliters in every liter. So to change this to liters, I divide it by 1,000. And this will give me 0.25 liters. Yes, we got it, ladies and gentlemen. We got it. Emmanuel, you got it? Is that you? You got a question? Oh, Deluxo. Gone. Oh, I thought someone had a question. All right, sounded like Emmanuel first. Okay. I hope we're all getting the same answer. If at any point you're not sure why, please don't keep quiet. Don't hold your peace. Speak. All right, raise your hand. Send a private message. Say, sir, why am I getting this? Why are you getting that? Why did you do this? What I'm doing that. All right, so please speak. Don't hold your peace. All right, but we're moving on to another question. Okay, here we go. What do we have here? A dairy truck. A dairy truck has a cylindrical tank that is used to transport juice. The tank has a radius of 1.5 meters and a length of 3 meters. So the first thing I do is I'm going to draw this onto the diagram. I need a dimension there, and I need a dimension here for the radius, right? Because the back of this tank, let me do that in the back. The back of this tank is a circle. All right. So this circle at the back of the tank here has got to have the radius. Okay. So I'm just drawing it here for you on the side. So it needs the radius there. Okay. So instead of a cylinder that's drawn straight up, all right, it's a cylinder on its side. Now, don't be confused. If I drew the cylinder straight up, I would call this thing, this dimension over here, height, right? I would call this dimension here the height. They've dropped the cylinder onto its side. Okay, so now the cylinder is on its side like this. All right, we still need a radius, but this dimension here, the blue one, which was a height, they're now calling length. Don't be confused, it's the same thing. All right, but because the cylinder is on its side, they're not saying height anymore. It wouldn't make sense to say height. Okay, so because the cylinder is on its side now, they're calling it length. Okay. Tandro, I wouldn't say base length, because the base of this shape is still the circle. All right. So the base is still the circle. So we had the circle base there when it was standing straight up. We got the circle base when it's lying down, which is this circle that I've drawn here on the right hand side, which is also, if I can draw it very carefully onto my diagram, It's this circle here at the back of the truck. Okay, so that's what I've redrawn as a circle. All right. Okay, so the length here, we used to know it as height. I'll put it in brackets there, height. It's the same thing. They've just moved the cylinder over onto its side. All right. So the H that we have here, instead of calling it height, they've called it length. It's the same dimension. Okay. Yes, Isabella wants to get on with it, saying, "Sir, come on. We know the formula. Let's work out the volume of this thing." All right. So Isabella, I've got a length there, which is actually the height, and the radius here is 1,5. So I'm going to write here 1,5 meters. And the length here is 3 meters. There we go. So those are the two dimensions we need. Okay, they're going to ask volume. There we go. There it is in the question. Calculate the volume of the tanker using the formula V is equal to pi R squared and H. Now you see this. This is one point, ladies and gentlemen. This is what they do. They call this dimension at the top of the tank length, but then they give you the formula with an H. And then the students go, huh? They're telling me length. Where's the H? It's the same thing. All right. Do not be confused. This H here in the formula is this H here in the standing cylinder. It's this length here in the cylinder on its side. It's the same thing. Do not let them trick you. Okay. R is the radius and H is the height. In this case, they're kind enough to say, in this case, don't be confused. It's the length. So these examiners are very kind to say, don't worry. If we say H, we actually mean the length. Okay. Use the formula to calculate. There's two parts to this. Use the formula to calculate the capacity of the tank in liters. Right, so let's work out the volume first. I want you guys to work out the volume first. We'll check that, and then we'll change to liters. Otherwise, you can do the whole thing in one shooting match and then say done. All right, you can say the whole thing in one bang shooting match and say done. I'll move a little bit up so you can see the volume formula and the dimensions on the screen. You go ahead, work out the volume, and then change it to capacity. They want liters. And I'll write this here, 1 cubic meter is 1,000 liters. All right, I'll write the conversion here. 1 cubic meter is 1 kiloliter, which is equal to 1,000 liters. They want to know the capacity of this tank in liters. That's what they want to know. So work out the volume first, and then change it to capacity using this conversion that I've just written on the screen here. And when you're done with all of that, say done, and then we'll go over it. And ladies and gents, make sure that if you have any questions, send us a message. Yo, Samuel says he's done already. Samuel is done. Yo, cold makes people work fast.
Yeah, they are bringing the heat, eh? They are 100% bringing the heat.
They're bringing the heat. I like that. Yo. I can just imagine people like Tiamo and Bianca like, yo, what's going on here? These people are fast. On another level. Yo, now ladies, finished. What is this? It's nothing. What they're trying to do here, they're trying to trick us. It's nothing. Excellent, Tando. Nice, Ben. Well done. Luto, well done. Good job. Good job. All right, give you a minute or two. You guys are working well. We need cold weather every time for our lessons. All right, we'll do one more minute, and then I'll start working on it. If I start working on it and you're still working on it, don't worry. You carry on and just check the answer at the end, okay? So don't feel like you got to stop. You carry on until you get your answer, and then just check it at the end. And if I move on, you say, sir, go back. I need to check my answer. Okay. let's say, sorry, say Dale. Say, Dale, please go back. I need to check my answer. All right, let's have a look. First, we need to calculate volume, and then we need to change it to capacity. Okay, so the radius is 1,5. The height, in this case, length is 3. So volume is equal to pi. We're going to say 3,142 for that, times the radius, which is, I love brackets. I love using brackets. Yeah, so it's 1,5. That must be squared. And the height, they say here, is 3 meters. All right, so it's put my units in there. I need to work this out on a calculator. All right, calculator, come here, do the work. 3.1.42 times 1,5, and this is to the power of 2. And then I times by 3, and that gives me 21,2085. I'm going to write this out in full. 21,2085 meters cubed. 21,2085 meters cubed. Okay, I don't want to chop that off. You only round off at the end of the answer. Right, so that's my volume in meters cubed. Now they give me a conversion here. I need to get to liters. All right, so every 1 cubic meter is 1,000 liters. I've got 21 cubic meters, and every one of those is 1,000 liters. So I need to times this by 1,000. Because every 1 cubic meter is 1,000 liters. So I need to times this by 1,000. Take my answer and times it by 1,000. And I get 21,208,5. 21,208,5 liters. We all getting that? All right. So please help me understand why is the cylinder is looking up or straight edge, and one of these else could be whether to use which one. Yeah, this is what I worry about, eh? So this question, Isabella, they say the formula asks for height. And guys, just check the answer there. Take a screenshot if you need to. 21,208,5. We'll come back to that now. So if I go up here to the drawing of a cylinder, this drawing asks for a height. Okay. So if I toppled the cylinder over and drew it on its side, then the dimension they want for the H is over here. All right? It's that one. Now, it would be funny to call that a height, right? Because it's horizontal. So what people often do is they change the name of it. So in this question, they didn't call it a height. They called it a length, which makes sense because it's a long, it's long, right? It's horizontal long. So they called it L here in this case instead of H. It's the same thing. It's just that they've toppled the cylinder over. Instead of height now, it's a long dimension, a dimension along horizontally. So they called it length here in this case. But in this question, they did remind you and say, don't worry, we have changed the name of it. But just know that when we say length, it actually means height. So the formula is asking for a height, and then they say in the bracket, H is the height, but in this case, it's length. Now, usually they don't write this part here in brackets. They just leave it. And you've got to know that in this case, you've seen, I've drawn it over here. In this case, it's a cylinder lying down, and the length they're talking about is the height that the formula wants. Okay, so you've got to know that. Otherwise, they write this very kind of little bracket here, but often they don't. So you've got to not be confused. They're trying to not confuse anyone with the word length. You should know it yourself, but they are helping people that are like confused. Why are they saying length here? Well, actually, it's the height. If the cylinder's just lying down, so you can't really call it height. Okay, I hope that makes sense. Let's come back to the answer now. Are we all happy with this answer? You all happy while we're getting this answer? Isabella, check and see the calculations and check where we are different. Okay, I'll show you what my calculator's got on it. So that's what my calculator has on it. It's 3,142. It's 1,5 squared, and then you multiply by 3. That should give you 21,2085 meters cubed. And every meter cubed is 1,000 liters. So I've got to take my 21,2085 cubic meters and times by 1,000 to get 21,208,5. Now, a point I want to make is, and often this happens, if you did this on the calculator, right? If you got this answer in the calculator, how many of you try to round that off to 21,21? How many of you did this, 21,21 meters cubed. If you did that, your answer at the end would be 21,210,0 liters, which is different to 21,208,5 liters, and not a little bit different. It's actually quite a lot. You are 1.5 liters off. Difference here. Okay, so some of you might have done, yes, some of you might have done that, and you might actually get the question wrong, the answer wrong here. You might lose a mark for the answer here because you rounded off during the question. You only round off at the end of a question. Okay, some examiners make allowance for this, but the memo, the matric memo should read 21,208,5 because you only round off at the end of a question. Do not round off during a question. Okay, so some of you might have a slightly different answer to that. Okay, next question. Here we go. Determine how many juice cartons can be filled from one tanker truck. Now, what are they talking about? It's a linked question, ladies and gentlemen. Do you remember our carton that we were working out? All right. Do you remember our carton here? It's the same company. Okay. So this question here, question 2 said, how many liters of juice can each carton fill? Each carton has 0.25 liters of juice. All right. Then we come down here and they say, determine how many juice cartons can be filled from one tanker truck. So how many cartons can come out of this tanker truck here if they had to fill juice cartons from the juice from this tanker truck? I'll write the juice carton volume. It was over here. All right, 0.25 liters. There it is. How many juice cartons can we get out of this tanker truck? Shouldn't take you long to work that out. All right, good job, Ben. What answer did you get, Ben? Let's put it in chat there for me. 84. Ben. We need to check on that, Ben, because the tanker can hold 21,210 liters of juice. Sorry, 21,208.5 liters of juice. And our juice cartons each hold 1/4 of a liter. So yeah, that number Bianca has, well done Bianca, that 840 is very big, but yeah, it needs to be pretty big. 84, that looks better. Bianca, that looks better. There we go. All right, so how do we work it out? So how many cartons can we get out of this tanker? All right, we're going to use this figure, okay? Because we're not rounding off during the question. So this is the one we're going to use. So we're going to say the tanker holds 21,208.5 liters, and a carton is 0.25. How many cartons are there? Cut the tanker volume up into the carton volume. So divide the tanker volume by 0.25 liters, and see how many you have. All right, so there it is on the calculator, still ready to go. In fact, this needs to be multiplied. That's the different answer. There it is. All right, now just divide this by 0.25, because each carton is 0.25. 84834. 84834 cartons. Well done. You all happy with that? You should all be happy with that. Shout if you're not. Okay. Are there any questions so far, or can I move on to the cracker at the end of the lesson? The cracker question. All right. All right, good. Here's the cracker. I don't know if I should show you this right at the end of the lesson. We need to get going soon. But take a screenshot if you can't finish it. And I tell you what, on Tuesday, we will go over this. Let me just talk about the question and then keep it for homework. But it says a 20,000 centimeter cube cylindrical bucket has a diameter of 10.5 inches. All right. So it's a bucket. It has a diameter of 10.5 inches, and it doesn't say anything about a height. But they give us this value here. What is that? What is this thing? 20,000 centimeters cubed. That is volume. I'll put a V there for volume. Bianca's running. I'll put a V there for volume. That is a volume that they've given us. So in the formula, V equals, this is cylinder. So it's pi times R squared times height. They've given us a volume. They've given us a diameter. We can work out radius, but they haven't given us a height. So here's the question. Determine the height in centimeters. Yo, I told you it's a cracker. Take a screenshot. I'll zoom out a little bit. Take a screenshot of that. And we are going to cover this question next week. Let's see who can get this one.